Today, we're diving into a scientific breakthrough that honestly sounds like it's pulled straight from the pages of a science fiction novel.
I mean, just think about that for a second. What if you could take totally polluted, undrinkable water and with nothing more than the power of the sun, make it pure? It sounds impossible, right? Well, as we're about to see, it's getting shockingly close to reality.
But before we get to the solution, let's talk about why this is such a huge deal. We really have to understand the scale of the problem we're facing.
Look, it's no secret that fresh water is becoming a massive issue. As our population grows and industry expands, we're putting a huge strain on our planet's resources. And our current methods for cleaning water, they can be super expensive, they burn through a ton of energy, and sometimes they even create their own nasty waste. We desperately need a better way.
And that's where this new research comes in. This is the new ray of hope, a brand new material that could be a total game changer. The secret ingredient here is a special kind of nanomaterial called a mexene, specifically one made from titanium and carbon. The easiest way to think of these things is like ultra-thin, two-dimensional sheets that are absolute superstars at one thing, absorbing sunlight and turning it into heat. They're like tiny, perfect solar engines.
So how do you take these microscopic sheets and turn them into a water purifier? Well, the process starts with a base material, and researchers use a chemical process to basically peel away layers, isolating these incredible mxene sheets. Then they mix them with something called alginate, which is really just a natural polymer that comes from seaweed. It acts as the glue, the scaffold that holds the whole thing together.
And the way they build it is just so clever and simple. They create the mixture, freeze it solid, and then put it through this innovative freeze-thaw cycle. Now, this step is absolutely crucial because it means they don't have to use expensive, energy-guzzling equipment. That alone could make this whole process way cheaper and easier to scale up for the real world.
And this is the final result. It's an aerogel. It's incredibly lightweight, it's dark, and it's full of tiny pores. You can really just think of it as a super-powered black sponge, designed for one specific job, to work with sunlight and water.
Okay, so we've got our sponge, but how in the world does it actually clean water? Right, let's get into the science of it.
This is the core of it all. When sunlight hits this material, the mxene particles go to work. They kick off this amazing phenomenon with a very fancy name, localized surface plasmon resonance. But all you really need to know is this. Those mxene sheets act like millions of tiny antennas for sunlight. When the light hits, electrons on the surface start vibrating like crazy, and all that vibration creates intense, focused heat right at the surface where the water is, which is exactly where you need it for super fast evaporation.
And this thing is incredibly good at its job. Get this, the research showed it absorbs over 90% of the sunlight that hits it. That is just ridiculously efficient. It's a near-perfect solar collector, making sure almost no energy gets wasted.
But soaking up sun is only half the battle. The structure itself is key. If you look at these microscopic images, the one on the left is just the base alginate. It has some pores. But now look at the one on the right after adding the mxene. Wow, you get this fantastic, perfectly formed honeycomb network. These pores act like superhighways, wicking water up and letting steam escape with ease.
In fact, this thing is an unbelievable 99.87% porous. It's almost entirely empty space. So that structure does two crucial things. It lets the material soak up water almost instantly, and it provides an easy escape route for all the steam it's generating.
So, the theory is solid. The material looks amazing. But does it actually work? Let's check out the results.
First up, efficiency. The aerogel clocked in at an 86.09% solar-to-vapor efficiency. Put simply, that means it does an amazing job of turning the sunlight it catches directly into steam, leaving all the nasty stuff behind.
And it is fast. It generated clean water vapor at a rate of 2.09 kilograms per square meter per hour. To put that in perspective, that's about 3.5 times faster than water just evaporating by itself out in the sun.
And here it is. This is the most dramatic proof you could ask for. Those little vials show it all. On the left, you have this dark, gross wastewater polluted with dye. And on the right, the water after it's been treated. It's crystal clear. The results are just undeniable.
But what about salt? Can it desalinate seawater? You bet it can. This table shows the data. Just look at the sodium ions. They drop from almost 11,000 milligrams per liter all the way down to just 8.6. That's a removal rate of over 99.9%. It is an incredibly effective desalination machine.
And this chart really sums it all up perfectly.
On the left, that's the evaporation rate of plain water. In the middle, the base material gives it a little boost. But then on the right, our MXene aerogel just blows them both away. It's not even a competition.
Okay, so it's powerful, it's efficient. But for a technology to really be the future, it has to be two more things: durable and sustainable.
Well, here's a chart tracking its performance over 5 straight days of use. And as you can see, it stays remarkably stable. The rate only drops by about 7.6% by the 5th day. That tells us this material is tough enough for repeated, real-world use.
And honestly, this might be the real game changer. The researchers were actually able to recover the valuable MXene from the used aerogels. So the key ingredient isn't a one-and-done product. It can be recycled and put into brand new aerogels. That's fantastic for keeping costs down and for the environment.
So let's just recap what we have here. We have a technology made from simple ingredients with a cost-effective process. It uses free energy from the sun to clean even the most contaminated water. And on top of all that, it's durable and it's recyclable. It really makes you stop and wonder and gives you some real hope for what our future with water could look like.